Hello, dear viewers. Welcome to the latest video from Bilal Consultancy Limited. Today, we're taking a deep dive into the world of Lean Six Sigma for chemical engineers, where we'll explore an integrated approach for achieving optimal outcomes. Lean Six Sigma's potency lies in its comprehensive approach. It's not just about removing inefficiencies, it's about optimizing processes to achieve the best possible outcomes. For the chemical engineering field, this integrated approach is the key to balancing efficiency, quality, and safety. Deep dive into Lean for chemical engineers. 1. Resource optimization. Chemical engineering projects often demand a plethora of resources, from raw materials to human expertise. The Lean methodology emphasizes the optimal use of these resources, ensuring that nothing goes to waste. This can manifest as using just the right amount of raw material, ensuring energy efficiency in a chemical reaction, or optimizing a process to reduce man-hours. 2. Process streamlining. Chemical processes can be notoriously complex. Lean's emphasis on simplifying and streamlining can help engineers redesign these processes, making them more efficient, less error-prone, and easier to monitor and control. Six Sigma's answer to variability. Six Sigma, characterized by its DMAIC, define, measure, analyze, improve, control, approach, is particularly pertinent in scenarios with high variability. This could range from inconsistent raw material quality to fluctuations in process parameters. A closer look at Six Sigma for chemical engineers. 1. Data-driven decisions. Chemical engineering, by nature, is data-intensive. Six Sigma's emphasis on data analysis can help engineers make better decisions, whether it's adjusting a reaction's parameters, choosing materials, or controlling quality. 2. Root cause analysis. When things go wrong in a chemical process, it's crucial to understand why. Six Sigma's tools, like the fishbone diagram or the 5 whys, can be invaluable in pinpointing the root causes of issues. 3. Statistical process control, SPC. This Six Sigma tool is especially relevant for chemical engineers. SPC involves using statistical methods to monitor and control a process, ensuring it operates at its full potential. Case studies and practical applications. 1. Batch processing efficiency. A global chemical producer faced issues with batch processing times. Utilizing Lean principles, the company re-evaluated its entire workflow. Redundant steps were eliminated, equipment was optimized, and workflow was streamlined, resulting in a 30% reduction in batch processing times. 2. Supply chain management. A petrochemical firm struggled with its supply chain, leading to frequent raw material shortages. With Six Sigma analysis, the firm identified bottlenecks and inefficiencies in its procurement process. Adjustments led to a more reliable supply chain, reduced downtimes, and enhanced production rates. 3. Quality control in pharmaceuticals. A pharmaceutical company used Six Sigma to improve the quality control of its drug manufacturing process. By analyzing data, the company identified factors causing inconsistencies in the final product. Through targeted interventions, they achieved a 99.7% consistency rate, ensuring safer and more reliable medications for patients. Let's talk about the first case study. Inventory challenges at a leading polymer producer. Introduction. A leading global polymer producer, with a rich history of innovation and a diverse product portfolio, found itself grappling with mounting challenges related to inventory management. High carrying costs, overproduction, and an inefficient supply chain threatened to erode the company's profits and competitive edge. The problem. Despite being a market leader, the company began to notice that its working capital was getting tied up in stored raw materials and unsold finished products. Warehouses were overflowing, leading to increased storage costs, risks of material degradation, and even wastage due to the short shelf life of certain polymers. The production floors were consistently churning out products, but the sales did not always align with the production rates, leading to a mismatch. The company's supply chain, which should have been a smooth conveyor from raw materials to finished goods to customer delivery, showed evident signs of strain. The Lean intervention. Recognizing the urgency of the situation, the company turned to lean principles for a solution. A team of experts was assembled to meticulously map out the entire supply chain, from procurement of raw materials to production, storage, and distribution. Using Value Stream Mapping, VSM, the team identified areas of excessive inventory, both in raw materials awaiting production and finished goods awaiting dispatch. Bottlenecks, points in the production process that delayed the overall flow. Overproduction, production that was not aligned with the actual market demand. Unutilized talent, employees' skills that were underused due to time spent managing overflows and backlogs. The solutions implemented. Just-in-time production, JIT, one of the cornerstones of Lean. JIT was employed to ensure that products were only manufactured when there was a demand. This approach minimized overproduction and reduced the need for vast storage spaces. Demand forecasting. By using advanced analytics and collaborating closely with sales and marketing teams, the company could predict demand more accurately, aligning production schedules accordingly. Supplier partnerships. To avoid hiccups in raw material availability due to JIT, strong partnerships were forged with suppliers. This ensured timely raw material delivery, maintaining a smooth production flow. Employee training. Employees were trained not just in their specific roles but also in understanding the broader supply chain. This holistic view enabled them to make more informed decisions daily. Outcomes. Post-implementation of these changes, the company reported a significant reduction in inventory costs. Warehousing needs were reduced by 40%, freeing up capital for other investments. Production became more streamlined, responsive, and agile, aligning closely with market demand. Moreover, the newfound efficiency also led to a boost in employee morale, as they could witness the tangible positive outcomes of their efforts. Conclusion. This case underscores the transformative power of lean methodologies. By addressing the root causes of inefficiencies and implementing strategic changes, the polymer producer not only optimized its supply chain but also fortified its position in a competitive market. Let's talk about the second case study. Resolving quality issues at a leading pharmaceutical company. Introduction. A top-tier pharmaceutical giant, renowned for its innovative drug solutions and vast global reach, found itself facing an escalating problem. One of its pivotal drugs, critical both from a revenue and a patient impact standpoint, was facing alarmingly high rejection rates during the quality assurance stage. This not only posed a risk to its market reputation but also created significant financial setbacks. The dilemma. Quality assurance in the pharmaceutical sector is non-negotiable. However, a consistently high rejection rate hinted at deep-seated issues in the production process. The ramifications were multifold. Financial impact. The rejected batches meant monetary losses in terms of both raw materials and man-hours. Supply chain disruptions. High rejections meant the finished product wasn't reaching the distributors and end users on time. Reputation. Consistent quality issues could tarnish the company's hard-earned reputation. Employing Six Sigma. Understanding the gravity of the situation, the company turned to the proven Six Sigma methodology, specifically the DMAIC, define, measure, analyze, improve, control, approach, to rigorously address and rectify the issue. Define. The primary problem was isolated excessive variability in the final drug's quality leading to a high rejection rate. This stage also involved identifying the key stakeholders, setting the project scope, and determining the resources needed. Measure. This phase was all about data. The company undertook a detailed study of the current processes, documenting every step. Critical data regarding the rejection rates, batch inconsistencies, and specific quality issues were meticulously recorded. Analyze. With the data in hand, the team employed statistical tools to discern patterns. After an exhaustive analysis, several potential causes for the inconsistency were pinpointed. This ranged from variability in raw materials and machinery calibration issues, to variations in the environmental conditions within the manufacturing units. Improve. Armed with insights from the analysis, the company moved to rectify the issues. Raw material suppliers were evaluated, machinery underwent rigorous recalibration, and stringent environmental controls were put in place. Additionally, staff training programs were initiated to ensure consistency and adherence to revised protocols. Control. Change is futile without consistent monitoring. To ensure the improvements were sustainable, the company set up continuous monitoring mechanisms. This involved both advanced analytics tools and manual checks. Regular audits were introduced, and feedback loops were established to ensure early detection and rectification of any future anomalies. Results. Post the DMAIC project's culmination, the outcomes were nothing short of transformative. The company reported a staggering 60% reduction in the rejection rate of the drug. This directly translated to substantial cost savings on raw materials and production, improved delivery timelines, ensuring consistent drug availability in the market, enhanced reputation, with the company being lauded for its commitment to quality and rapid problem resolution. Conclusion. This case is a testament to Six Sigma's power in addressing and rectifying quality concerns in a systematic, data-driven manner. The pharmaceutical giant not only managed to curtail its immediate losses but also reinforced its commitment to quality, reaffirming its position as a market leader. Thank you for joining us on this journey into Lean Six Sigma for chemical engineers. Don't forget to like, subscribe, and hit that notification bell to stay updated with more insightful content from Balal Consultancy Limited.